All right, welcome back, flight engineers. So we're working on our experiments in flight, of course, leading to our culminating activity. Last week we examined thrust. You built sprockets with different variations, and you propelled them by creating thrust by blowing into a straw. We're going to examine thrust again, but on a more practical level, and basically similar to how they use rocket propulsion. So what we're using is balloons, varying sizes, and you'll be doing a number of different experiments. You'll notice at the back of class there's a fishing line that runs from the cupboard to the front of the class with a straw on top, and that will be your test pad or your launching pad. You're going to be using a round balloon, a thin balloon. So the first part of the experiment, basically, you're going to take the larger round balloon, blow it up as big as you can, completely, of course, without popping it, making sure you're pinching the end. Then you're going to head back to the class. There'll be some masking tape. You're going to take the balloon, take the straw carefully, tape the straw to the balloon, let her go, and of course measure how far the balloon travels along the straw. So that's the first one. You're going to take the very same balloon, gently take the tape off using the same balloon, blow it up 3/4 full. Then you're going to launch it again, blow it up half, and then blow it up 1/4. So you've done it 4 times, measuring the distance to see if the volume of air inside the balloon makes a difference. So that'll be the first sets of experiments. Then what you're going to do is you're going to come to me and get a round balloon, a thin balloon, sorry. This is the thin one. These ones are clown balloons to make crazy animals. What I need you to do is tie off the end with a little knot so we don't have a super, super long balloon. Okay, so there's a little knot. Use a special pump because you cannot blow these up otherwise. And blow up your balloon. Okay, again to the knot, pinch it off, comme ci, hold it on top of the straw, and then there's a camera there, throw the straw, let her go, and then measure it off. Okay, then we're going to return back to the round balloon, and this will be the extension of your experiment, because what we're going to try to do is see if we can control the airflow coming out of the back of the balloon. Because if the air travels out slowly, the balloon may not move at all. If the air travels out too fast, it may only go a short distance. What scientists and rocket engineers and those studying flight want to do is they want to have a consistent thrust, strong enough to create lift and move the plane, but consistent so that it doesn't burn out and you have to lose a lot of fuel or you don't go the farthest distance you can. So is there a way you could control the way the air comes out of this so that it's consistent enough to move the balloon, yet strong enough and long enough to move it maybe even across the whole classroom? We don't know. I don't even know how far it could travel. That's the great thing about science. So those will be your set of experiments. Again, large balloon, full, 3/4, half, quarter, skinny balloon, and then can you control the propulsion system out of here? Okay. Then the questions we'll be asking is, what I really want you to focus on is explain the science behind how this is working. Okay, we know that we're blowing up the balloon and there's pressure. We know that gravity, because we looked at gravity, has pressure on the outside of the balloon, but how is this balloon traveling? What's happening to move this balloon? And I really want you to look at this in terms of scientific terms. So you may have to do some Googling for this one. Okay. A tip for this one would be Newton's laws of motion. So that's a very important thing. So again, one of Newton's laws of motion explains this principle perfectly. So you can combine the concept, what Newton was trying to do, or Newton actually figured out, to this, and also really get into the science of how this is working. Because basically the same principle was just expanded to rockets. And instead of using air, they use combustible fuels to create the thrust. All right. Happy rocketing and safe flying.